Okay, welcome to part 2 of the video because technology is my friend. Now, we're going to take the same graph that we just did all that cool stuff on, and we remembered what we talked about last year, and now we are going to play limits. Okay, so it's going to be a little like wishy-washy because you're going to be like up the screen, down the screen, but it's going to be okay. Oopsies, it's already not okay. Boop, 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 boop. There we go. And we found it. So we're going to see, here's our pretty graph with all the asymptotes that we had before. And then we're going to come down here and we're going to look about what it's saying. So the first one says, as x approaches negative infinity. So the first thing let's do a box around these two because they're doing the infinities, okay? The end, oh lordy be, end behavior. Okay, so now, just like promised, coming down. So as I approach negative infinity, okay, negative infinity is this way, right? Left of the graph. Zoop, boop, 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 boop. Where is it going? It's coming out and it's hitting that line, that asymptote there. So as it, no matter how far out it goes, we're going to say that that approaches that positive 3, okay? Now, let's get a new color for the next one. We'll go red. So the next one says, as I approach positive infinity. So positive infinity is going this way, bloop, 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 up, and it's hitting that same asymptote. Okay, so that we're going to say is hitting that same 3. So what does that look like in calculus notation? That looks like we're going to say the limit as x approaches infinity of f of x equals 3. Do this one in blue so we don't confuse ourselves. The limit as x approaches negative infinity of f of x is 3. Okay, so now the next 4 down here are talking about from the left and from the right. And then just really, this is to help my own brain here. We're going to first box. These are working with the number -3. And then these are working with the number positive 3. So let's deal with the -3 first and then go from there. So scroll up. I realize you don't have to do that. And we're going to talk about them both. Let me get some more colors going on here. If I take my -3 situation right here and I approach from the left, right? This is the left, and as I approach, it's headed where? It's headed all the way up to infinity. All right, so let's go down and write that. So that's this one. I say as x approaches -3 from the left, put the negative afterwards, of f of x, that went to infinity. All right, now, bloop, yellow sounds good. I'll regret that soon. Now I'm going to approach the -3 again, but this time I'm going to do it from the right. That means starting over here. It's going all the way down. All the way down is known as negative infinity. So this one we're going to write the limit as x approaches -3 from the right of f of x equals negative infinity. And so we've done those two. Now we're going to be looking around the positive 3. Oh, this blue is nice. Okay, so that, to remind you, is right there where the hole is, okay? So this is where we have to start tricking our brain. Not tricking our brain, just being awesome. The value does not exist, but we know what would be there, that 5/3. What is it approaching? So from loop. I'll go green. If I approach from the left, I get that 5/3. Okay, so let's go down and write that. From the left. the limit as x approaches 3 from the boo from the left of f of x is that 5/3. Go back up. Now, one more millionth color. I kind of like this one. Approach it from the right. All right, we're over here, still approaching that 5/3. Come down here, loop-a-doop-a-doop. The limit as x approaches 3 from the right of f of x is 5/3. Okay, so can you explain what the value of the limit represents in terms of the graph? The big thing, and we could write a whole paragraph, I need you to get out of this what it is approaching, regardless if there is a value there, okay? What it is approaching. So now the next layer of that, I want you to compare the two different columns here of approaching the -3 and approaching the +3. When I approached the -3, I had answers each time from the left and from the right, but notice they're different. When I approached 3 from +3 from the left and right, they approach the same thing. Okay, so we want to say if it's approaching the same thing from both sides, then without a left or a right, the limit would exist. If it does not, where I have the -3 from the right and the left, that limit of -3 does not exist because the two did not match. So we have here, we have the value of L if it approaches from either side. Okay. Now we're going to estimate values from a graph. Let's see if there's any way I can get this bigger. That seems to be... So the answer is no, I cannot change the size, but we have you have it in your packet. We have, let's talk about it. Graph is going on, blah, blah, blah. You should see the whole, okay? Over here, you should see the jump. You should just love it. So first we've got values. F of 2 is going to be this spot right there, correct? That's filled in, that's going to be -1. Well, let's figure out anything else with 2 right now and just do them all at the same time. That makes more sense. All right, so here I have in D, from the right. Okay, so I'm coming from the right, all right? As I approach there, where is it approaching? It approaches that hole at +1. So the limit as x approaches 2 from the right is 1. Let's do E. The limit as x approaches 2 from the left. There's the left approach. That comes up and approaches that filled-in circle at -1. So this is -1. And here's a boom, 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 we're making a moment here right now, okay? When you make a limit and you say I approach from the left, you get an answer. I approach from the right, I get an answer. If those two answers do not match, then your answer is does not exist, okay? Left and right must match. That's very hard to read. I'm going to just erase that. Okay? We're going to write it out nicely later. And while I'm fixing things, I'll fix the E. Okay, let's go. -1. -1. Oh, look, it's another weird spot. -1. -1 is happening right here. You can see there's the hole that occurs at -1, 2, and then also here's your value. Hello, up there at 4. I've covered it in so much. So here we go. First, f of negative 1 equals 4. Now let's go through and find all of them. All right, here we are. Negative 1 from the right. Negative 1 from the right. Right's over here, right? Right. It's approaching that open hole at 2. So from the right, it approaches 2. Come on, 2. Now, from the left, still approaching, same hole. Okay. All right. Okay. All right. Put that there. So now you're saying to self, we just did this. Okay, and the last one, from the left, from the right, were different answers. The limit did not exist. But in this cutie patootie, the values did match. The limit from the left and the right. Both 2. I'll write it here now. Left and right limit must match. Okay, so woo, that limit existed. What's the next thing they want? Oh, negative 4. Sure thing. Nope, that's positive 4. Totally lied to you, friends. Positive 4 from the left. Positive 4 from the left. Bushka. Positive 4 from the left. Popping up there at 3, right? Are there any other 4s on here? Positive 4 from the right. Coming up that hill. It's still approaching that 3. Yeah, you're excited right now, right? Woo! From the left, from the right, we're the same thing. Go find the 4 that it's asking from both sides. Now that's a negative 4. That's sad. Sorry, friends. They never asked about positive 4 from the right. Well, that was silly. All right, well, let's go do negative 4. Negative 4. Boop, boop, boop. Negative 4. So, looking here, now you'll notice this one comes up in the question. If you think the function is a highway and the image is traveling from left to right, x equals 4 from the right, not to the right. When you stop, okay, so it's approaching here. I have no marker. It's not the one they were talking about. I apologize. As I approach that negative 4 from the right, that negative 4 is going to be coming to that 2. So negative 4 from the right is 2. Now, as you look at the other side, you're like, we've finally figured this out. This is starting to get gross. Is there anything on this side over here? Do I have any way to kind of go? Okay, think of going to the Statue of Liberty by car, right? You can see it, it's there. But coming from the direction of the left, well, there's nothing there, okay? So there's no way to say what it's approaching because it does not exist. Okay, what do we have left? Oh, 5, 0, 1. Okay, let's do it. Let's do it, let's do it, let's do it. 5. As I approach 5, we're going through loopity bloopity 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 bloopity. It shows you right there. It's got the arrows. Now, this is a tricky because you're saying, oh, Bowen, what's happening here? Let me circle where I am. Nice mint. This, and then we already used mint. Red? Okay. What happened at negative 4 stopped. There was a point, stopped. The little arrow on the end means there's a line. The little line means it's going on like this. And you can see it's linear. Like they're very specific to tell you it's linear. So it's approaching with that same slope both sides. It's going to approach that negative 2 there. So the limit as I approach 5 is 2. Let's go back. The limit as I approach 0, left and right, they're both hitting the same thing. That's negative 1. And then as I approach 1, 1 is right here. Both sides approaching the same thing. Got the -2. -2. All right, continue. Think about it. First of all, two weird situations. At 2, -1. Okay. 2, -1. 2, -1. 2, -1. 2, -1. Oh, we had a situation there. So at 2, -1, that's where we had the jump, right? And then at 2, 1, it just came to an end, okay? So that's where we have a 2, 1. We're going to say we have a dead end without a barrier. Now 4, 3. What are they asking about 4, 3? 4, 3. Ooh, now 4, 3. Ooh, that looks special. Very special. I want you to notice at 4, 3, it looks very sharp there. Very sharp corner. We're going to talk about what each of those did as we get more into this. All right, continue. We have cases here. Okay. So, 3 limits. They're not going to work. Does not exist, is not working. If we have this jump situation, okay? So in the first one, the way we check this, and we say, okay, the limit, I like this chocolate color. As x approaches -1 from the left is going to be -1. The limit as x approaches -1 from the right is positive. Now, as we've done it now, as I approach -1, the left answer and the right answer, they both existed, but they did not match each other. We're going to say that does not exist. Okay, so that's our first sum right here. If we have limits that are different, left and right. Ooh, look at that pretty situation. Okay. This is what's called oscillating. Come on, El. One L. Yep. 2 L's. Now, if you look at this and you go, okay, I don't know what's happening there. As I get closer, it looks like it's going to 0. It might be, I don't know. Here's where you would then go in and look at small values. Okay, you're going to plug in. If I plug in 0.1 and I plug in -0.1, when I get those out, okay, so then f of x here. So if I plug it in smaller value, all right, if I say from 0 from the left, that's less than 0. And if I do it from the right, that's more than 0. And that's just by plugging in those values. And once those don't match, then you can say, okay, does not exist. Now, right here. The third one is when we are approaching. We're going to say unbounded. Now, here's where it gets tricky. As I approach from the left and the right there, they're both approaching infinity. As x approaches 2 from the left, it's approaching infinity. As I approach 2 from right. It's approaching infinity. Now you're going, what happened? Hello? You just said, that's right. Well, the limit does exist, right? But since I can't say that infinity is a real number, I couldn't say it has that value there, okay? So a limit approaches infinity, but by definition, infinity, it does not have a real number at the end behavior, okay? We're almost done with this video, I promise you. Now, just to save us some time, I'm going to calculate this while you're paused, and then we'll come back together. Okay, magically I've created our table for us. I did that by plugging in the values or the function and getting values out. You're going to notice here, this is the first time we're going to start to talk about this. Write 4 digits whenever you're working in the middle of a problem. When you finish answers, you write 3 digits. That's just the rules of calculus. I didn't make them, I just follow them. So now we look around and you'll notice I went 2.9, 2.99, 2.9999. Same thing over here, 3.0101. There we go. As much small, getting close. So as I look at 3 is undefined, so that wouldn't help for actually finding it. From the left, the closest I get is right here. Okay, so that's going to get this. Boop. 1, 2, 5. From the right, the closest I get is right there. So if those match, then we're set, okay? And again, what we're doing here, and there's a whole paragraph you can read about it. One, we're looking at where are they going towards. Yes, 1.249 is not the same as 1.250. Think how small that is. Doesn't matter. So you want to look at where are things going. Right, so no matter how things are going, it's important. Here, put a box. If a limit exists, if the value of the limit to the left equals the value to the front right. Okay, this is the big stuff. Now, here, in this number 6, we're going to go over it and we'll talk about it. I'm going to say in class. I don't know what that means this year, but on the Zoom, we'll do it together. And I want you to talk about it. I want you to think about how you would explain to someone who has not watched the video yet of what the mumbo jumbo of the definition of a limit is and where all the pieces kind of look like it. Okay, now, and then these last 2 here, I want to like repeat 7,000 times. This is just one that I'm drawing, okay? I want you to pause the video. It's been 23 minutes. You probably need to like get a snack at this point anyways. And draw it and then come back and look at my example. Oh, good. You've paused it. Excellent. Really enjoying this sky blue. So here we go. We're going to label this is x. This is f of x. Put this value a here. Okay, so it's a point of discontinuity. It's undefined and the limit exists. When I hear this combo of things that it doesn't have a value, I usually go to whole, okay? And if it's a whole, it is discontinuous there. Continuous means that I did not pick up my pencil, or more formal as you're seeing here, the limit wasn't the same as the value. And the limit exists. So I'm going to just draw a squiggle, give it a hole, and party on. Okay? That meets all the requirements. Limit exists. It is discontinuity, and then it is undefined. Okie dokie. All right. Now the second one, they were more specific that it has a jump. Let's see if I can move my face over here this time. You can just stop. Boop. All right. Of course, you've thought about it. Now this one is saying that the limit does not exist at A. It has a jump discontinuity and A is defined. All right, well, so it wants a jump. Boop, A. This is my x. This is my f of x. So I'm going to go with a jump, and I'm going to say A is defined. It's that right there. And then it's going to jump right there. Now, thank you for sticking with me for 25 plus minutes. I hope you took breaks. I cannot wait to talk to you about all of this wonderful stuff and to meet you and all of the above. I promise we're going to have so much fun. All right. Bye-bye. Miss you. Happy afternoon, evening, whatever it is.